All right, here we are at the final lesson of Unit 1. So hopefully all these video lessons you've been trying to re-teach somebody using a blank slate and just constantly pausing these videos and seeing how far you can get on your own. So we're still on this final objective Keystone topic, but this time we're going to focus specifically on the relationship between structure and function. So in biology, one of the most common structures you're going to see are things that are branched out or things that are folded. And they're both branched out and folded for the same reason. So in other words, why are plant roots branched out? Your lungs are also branched out. If you took a microscope and just zoomed in on your lungs and zoomed in, I know they're inside your body, but if you could, you would see that your lungs also branch out like tree branches. And why are tree branches branched out? And so on. So, some common examples would be plant roots. If you pull a plant out of the ground, you'll see the roots are just branched out. Lungs are branched out into these tiny little millions of branches called little sacs called alveoli. Why is that? Right, now this is going to be a little bit repetitive, but it's worth writing over and over again because it's such an important concept. Anytime in biology a structure is branched out, it is to increase surface area, right? And so the general reason why you want to increase surface area or contact with the surface is to allow more whatever it is to pass through, or whatever is to get absorbed. All right. So the question might be like, why are plant roots branched out? And you would say, well, they're branched out structure to increase surface area. So more water can be absorbed because that's the job of plant roots. They will absorb water and nutrients. Now the question says, why are lungs branched out into alveoli? The answer is, lungs are branched out, there's your structure, to increase surface area so more gases can pass through. Gases, oxygen in, carbon dioxide out. So these blanks are going to depend on what the question is asking you. But if the structure is branched out, there is your generic format. All right, the other very common structure is when something is folded. And again, the reason is anything in biology is folded is the same reason. So I'm going to write this again. It is that important to increase surface area, right? And back to, oops, thought that was to the end reason over there again. So some examples over here, right? The inner linings of your gut, your small intestines, for example. The mitochondria, the inner membrane of the mitochondria. Gills, fish gills. There's a lot of examples. Chloroplasts, inside of chloroplasts, they're folded. So if you get a question like, why are fish gills folded? You would say the fish gills are folded to increase surface area. And then you've got to match what the function of the gills is so more gases can pass through. Again, oxygen in, carbon dioxide out. Why are the intestines folded on the inside? Well, they're folded to increase surface area so more nutrients from food can be absorbed. The fill in the blanks here is going to depend on the what they're asking you. So I have this piece of paper, and let's just say its dimensions are 2 by 3. So to get the surface area, you just do length times width. 2 times 3 is 6. So I have a surface area of 6, let's just say, for this piece of paper. Now, in this space, I can only fit in one piece of paper. Surface area has? It has a surface area of 6. Now, if I fold the paper, the surface area didn't change. It's still 6, but it takes up less space. So what that means is I can put 2 papers that are folded into that same amount of original space. But what did I just do by folding it? I doubled the surface area. I have 6 here, I have 6 here. But now they all fit in that small original space. That was originally 1 piece of paper. Now I can fit 2. Wasn't the most impressive demonstration, but if you look at the filter paper in your home, if you live in a home, you have filters in probably every room or your central unit there. So take it out, you'll see it has like several folds, and again, that's to increase the surface area so more dust and particles can get trapped into that filter. All right, so anyway, there it is. Very, very common, very, very important. You'll get some kind of question as like, hey, explain why the structure of this thing is related to how it's related to its function, its job. All right, so this is the template you're going to use to answer those kind of questions.